Hi class, here's a basic idea on hypothesis tests. So there's going to be certain conditions that you're going to be testing and the proper way to test them. But here's the basic idea. Picture that your blue graph represents a population and then the actual purple one in this case, it represents a sample. Now, what you're going to be testing is it likely that the sample has the same value of a mean of a population? In this case, if you were to look at the graphs, you could say like, well, they look the same. And then somebody may mention that as that's being HO, the original hypothesis, or H1, an alternative hypothesis, depending on how they word it. So in this case, if we're just eyeballing both of those, they look pretty close. In reality, the mean of the normal distribution is 5, and then the actual mean of the sample is about 4.99. So yeah, they're pretty close. But then you're going to be looking at cases where you have the mean of the population, and then maybe they're going to modify to a sample. So in this case, the mean of the sample is actually near 15, and the mean of the population is 5. If you were to test it, in that case, you would say, no, it's not likely that the sample in this case comes from a population that has a specific value of 5. Now, for hypothesis tests, it's very technical. It's like going to court, and it has several actual aspects that need to be covered. So for this reading, as you look at the textbook, compare it to what I'm doing on the recorded lectures. On the recorded lectures, I'm just mentioning the bare minimum that's needed. In other words, each part of the hypothesis. That's actually it for this video. Like I said, it's a proper way of testing if samples happen to have a value of a parameter, and you're going to be testing for equality, greater, or less than.